Okay, yeah. Hello and good morning, everybody. Thanks for inviting me for this keynote here today at the ASPA World Conference, World Forum 2019. Okay, thanks. Usually when people ask me what I'm doing, okay, I'm a remote sensing specialist, and remote sensing is very often a term which is really not well known. So my first step is always to go in and say, okay, I'm working with satellite data or even airborne data, which is then much more known to people. Specifically when I say, okay, just take a look at Google Maps or Google Earth, and then you know what I'm working with. But Google Earth, of course, is not everything in remote sensing and in satellite data. Actually, it's just the visualization of our data that we use. Remote sensing is going much deeper, and here I hope I can show you a bit about or something about the new developments and things we are working on, and some examples of how we are going to in the future with remote sensing and satellite data, the usage of satellite data, specifically when it comes to arid lands, so dry lands in the world. First of all, I was really impressed in 2018 when I took a look at the COSPAR bulletin. I saw a lot of new satellites that has been sent into space, and I took a deeper look, and I was really impressed that only in the period from the 8th of November 2017 to the 6th of March 2018, so in a period of roughly 4 months, 143 new satellites have been started into the space. And out of these 143 new satellites, there have been just 40, or not just, there have already been 41 new satellites just for the purpose of Earth observations. So what we do in remote sensing, taking a look from space to the Earth. I think that's an incredible, let's say, huge number from my point of view. Within 4 months, 41 new satellites for us to work with. That's perfect for me as a scientist, but yeah, maybe it opens other questions. When we take a look further, this is just an example of the, let's say, most common satellite products or imaging products that are in space right now. Yeah, we have the Landsat product, we have MODIS, which is really well known in the world, and the 3 Sentinel data sets or Sentinel satellites from the Copernicus program. We see they are released so far mainly from the US and from the European Space Agency. They are meant all for different topics, mainly land, coastal, and ocean topics, but there are also satellites out, of course, for atmospherical topics and so on. The resolution is quite different from the different sensors, so we can address different topics. We can go for let's say, continental analysis or global analysis down to regional analysis. We can, only with these data sets, we can already do a lot. And all these data from those sensors here, they are really freely available for everybody in the world. No matter if you're a researcher, if you're coming from the administration, if you're coming from business, you can use them. You can build your own business just on those data. Current data, actual data, or historical data are also available here. This leads us into a totally different new, or leads us to totally new problems. On a daily basis, just some simple systems here produce already terabytes of new data, of new information. And there are several other Earth observation satellites out there which are operating in space from many other countries, like the Japanese, from China, from India, Canada, France, wherever, or even from private companies. There are a lot of satellites out there. So, from our point of view, data availability, at least when it comes to satellite data, is not an issue anymore. Very seldom You may have regions in the tropics where cloud cover is so much that you're still in trouble, but usually it's not a big issue anymore. The trouble now is more or less how do we handle all the masses of data? How are we capable to make the best value out of what is given? If you even want more information on existing missions, easily go to the webpage of the CEOS, Committee of Earth Observation Satellites. There you find information about all the missions that are right now in space, or even the planned missions and whatever. There are more than 60 space agencies put together all their information in this database, which is really nicely prepared and also open access. So, as I said, I'm a remote sensing specialist. So what is remote? Remote sensing is the science of acquiring information about the Earth's surface without actually being in touch with it, in contact with it. This is done by sensing and recording reflected or emitted energy and processes, analyzing and applying that information. And this is more and more getting important for us, that we find best ways to apply the information that we get out of the data, that we are capable to extract from the data. Mainly this is done by a, let's say, simple approach. We think about some remote sensing parameters, so we use our data, we talk about land use, land cover. We're trying to get information about surface characteristics like vegetation, soil, and water. What we need then is, of course, usually we take GIS information, some ancillary spatial data, some socioeconomic data, it may be from Earth observation as well. And with a geographical knowledge, an understanding of the setting and the processes and everything, we try to identify the best tailored models and applications that we can find. We combine these things together, and then we go back to the remote sensing data, apply everything on those, and at the end we try to extract information out of that. That's mainly the goal in this. Nowadays, it's getting a bit more, let's say, as I already said, we try to extract or to get the best information out of the masses of data that we have. So nowadays, it's the method which I showed here is not, let's say, that simple, straightforward anymore. In former times, most often people used one image to extract the data, to prepare a map, and the map was the final result. Nowadays, with the masses of data and with a different, or let's say with a huge number of different sensors, with a varying geometric resolution and information content of these data, we are forced to introduce and to develop new methodologies to make the best value out of this. So here, for instance, the image fusion technologies, they help us to combine data from different sensors, even if they have a different resolution, if they show different degrees of information or of detail, degrees of detail. Even if they show this, we can combine the information content of these sensors and try to get the best value out of this again. Yeah, we see here, for example, the different resolutions of Sentinel, Landsat, MODIS, and AVHR. Usually these data are very common and very well known in the remote sensing community. So I'm sorry that I use the abbreviations here for the sensors, but it will be long terms partially to write them all down. Yeah, as I said, image fusion technologies are used to use information from different sensors. This can even be optical and radar sensors. Yeah. The next thing is that we have to learn, or we know already, but we need to apply it much more. The information of the time series that are now available. We have seen that the Landsat sensor, at least, or the Landsat system, is delivering data since 1972. So far, there is not much, or we have not seen too much applications that really make use of all these informations that are there. Even with the new sensors, we get more information within a certain period. We get more data within 1 year, for instance. So it is not only that we should learn or that we should apply information, the data to extract information from the past. We even have to learn and to deal with the data, with the different data in a year. So to get even the phenological stages, to make use of the imaging of different phenological stages within 1 year. What we see here is an example of southern Egypt, of an irrigation scheme in southern Egypt, very close to the border of Sudan. To Sudan. We see the development from 1998 to 2019 of this irrigation scheme. So how it develops in space and in time, getting bigger and bigger and growing. But what we also see is the variation of the phenological stages of the plants within a year. This is also, from my point of view, very important that we apply these systems to talk about, at least when it comes to vegetation, we have to learn how to deal with these data. There is absolutely no way around anymore for us. The next thing, or as an example, what we do with this information is here from Central Asia, also again an irrigation scheme, where we know it was also produced or established this irrigation scheme in the desert zone of Central Asia. Afterwards, after the implementation, we know there is a certain production. We call it normal production here, but we know that very soon, within some years, maybe 10 years, maybe 5 years, depending on the field, depending on the soil conditions, and depending on other issues, we came from a normal production to low or no production. Here symbolized by the lower image, which shows a very salty crust, soil crust, a picture taken on a former agricultural field in Uzbekistan. So the question is here, of course, and this is what we try to solve then with these masses of remote sensing data. How do we come from a low production, or how can we assure that a normal production field stays at least in the normal production? Or why is one field acting like this, is going from normal to low production, and other fields not? What makes the difference? These are the questions that we try to answer for Central Asia here. We are still in the process, but I think it's very valid for the region because this country is really strongly related on agricultural production. The time series that I showed before, or a kind of this, Landsat time series for 1984 to 2016, that could be used to monitor rice production on the irrigated field, here in an example of Kazalinsk region in Kazakhstan. There was the question how the specific field has been used, or how the trend of rice production in the region has been. So is the production, let's say the yields of the field, is it somehow related to the number of fields that has been used to produce this in these areas? Now let's come to what we have done so far, to other topics that are more, where are we going to? What is the goals? What are the far-reaching goals that we want to reach? I think it is important that remote sensing is going away from just producing maps, just single time step maps or maps that that are very specific, we should think more in services and, of course, data. So coming directly from the image to a service. For instance, here again an example of the Central Asia region, where we established on the people at my department, they established a nice web tool where we which is meant to directly deliver services, so information to administration, so to policymakers. This can be, for instance, information about the land use area. Yeah. So what we see here, for instance, that's an irrigation scheme again in Uzbekistan. What we can see if we zoom in a bit, that some areas, for instance, reflect drought areas, drought years, like the years 2000, 2001, or 2008 and 2011, with a low intensity, with a lower, let's say, land use intensity than other areas do. For instance, this one here. We can clearly see that the area on the left side has clear depressions in the years where we register droughts. Yeah? And why do the other area doesn't show the same system? We think if there is a drought, all the areas should have drought effects. But no, in some areas it works still. And these are very interesting information, because this information can be used afterwards to think about, okay, what is working in the one area better than in the other? This is something where we, from the remote sensing, where we can deliver the area-wide information for comparison reasons here. Similar, you can see that in this tool that we set up, we have also indicators like water availability, so where we see how the water is used or is available in some areas, and then we see even that some of those areas have trouble by being provided with water. And then, of course, the final product out of this is when it comes to economic issues, that we can even talk about the economic revenue per cubic meter of water in this area, which is then again very interesting when you see about the productivity in these different areas. Another example where we work is West Africa. Even here we also started again with very simple basic maps. What is the land use? What is the land cover in this area? From that, we have been capable to increase the information content by even adding crop types, so that for each and every, let's say, parcel, we could identify the crop that has been growing there per year. From which, again, we then went a step further to identify crop cycles, because crop cycles in that region are really well known and as being a measure against climate change issues. Yeah, what crop cycles as measure to tackle the issues of climate change. And from these further data, we then, of course, we extract statistics, so to go to the policymakers and tell them, okay, here again, in this area, people are already adapted more than in the other areas. And potentially to lay a focus for the policymakers to say, okay, if you want to talk to people, if you want to change some things, go to those areas and instead of those. That was just the first step where we were. We are right now a step further in our work in the region of West Africa, where we try to combine all our scientific developments, where we try to combine all our data within a very new development of remote sensing, the so-called data cubes. Data cubes are meant to provide easy access to remote sensing data. In a data cube, the remote sensing data are already, let's say, prepared for easy usage for each and every user. What we do here in this project is, again, to even include methodologies that are already tested, that are, where we know how good they are working. We want to include even them into the data cube so that policymakers have an easy access to the data, an easy access to the methodologies, so to repeat on a yearly basis the same analysis. So means the same information, the same data. We combine this even with a strong capacity building component, but I will talk in some minutes about that. So the specific goal in this project phase right now is, let's say, get information about storage and release of carbon into the atmosphere. So issues that has to be addressed by the Paris Agreement, and where each and every country, at least in this region, has to deliver data on carbon emission, carbon storage, due to the NDC, so the nationally determined contributions to the Paris Agreement. And here we hope that we can provide data and information to the countries so that they can fulfill at the end their duties to this Paris Agreement. In Germany, we are maybe a step further already. The DLR, so the German Aerospace Center, together with the Ministry of Digital Infrastructure, has set up this Code.de, let's say, web-based platform, which not only the satellite data out of the Copernicus program are all freely available to the administration. They also include what I said before, the methodologies and everything to make the data, to get the information out of the data. So here in Germany, this is part of the ideas that I presented before are already established. This is a web platform meant for the administration, so for the German ministries or other administration levels, to go with their own data, with their own vector data, so their own cataster data, and get ready analysis from remote sensing data. Yeah, and one last very important issue we should never forget in remote sensing, and when we see that there are new developments and so on, it's always the capacity development, which is quite important, that specifically when it comes to regions like Western Africa, we do capacity development at this place, in the area. At certain universities, remote sensing is applied, and we go there by ourselves to lecture and to increase the knowledge in the region just for these new developments. And on the other side, we do it in Würzburg, in Germany, as well. We have a master's program on remote sensing of the environment, an international master's program. So we each and every year, since 4 years now, we welcome students from all over the world, from different parts of the world, and we are happy to see them and to see this master's program really growing and getting stronger and stronger. Yeah. That's from my side. Thank you very much. And yeah, thanks.